back to Leetcode Simplified. I'm Alan, and today we're walking through Leetcode 108. Convert sorted array to binary search tree. This is a classic problem where recursion really shines, and we're going to keep our solution clean, efficient, and balanced. Let's dive in. The problem is simple. We're given a sorted array of integers in ascending order, and we need to convert it into a height balanced binary search tree. Height balance means the depth of the left and right subtrees of every node differ by no more than 1. Our goal is to split the array in a way that keeps the tree balanced. Since the array is sorted, the middle element should be the root. That way, everything on the left becomes left subtree and everything on the right becomes right subtree. And we can repeat this process recursively to build the entire tree. This divide and conquer strategy ensures balance because we're always picking the midpoint. Now let's look at the code in detail. First, if the pass-in array is empty, no more elements to process, we return none to indicate that this branch of the tree ends here and doesn't create a node. Otherwise, we're going to find the midpoint index and create a node with the middle value. Make it root of this subtree. Recursively build the left subtree using all values before the root. And recursively build the right subtree using all values after the root. Finally, we return the root node of this subtree, which connects the whole thing together. This allows the recursive calls to connect everything together and build the full binary search tree from the bottom up. Now let's take a look at the example on the left. We want to convert the sorted array -10, -3, 0, 5, 9 to height balanced binary search tree. Let's go ahead and run the function passing on this array. We take the middle element and build a node with its value. Make it the root of the left subtree and the right subtree. For the left subtree, we call the function again, passing all the elements before 0. For the right subtree, we do the same, call the function itself, passing all the elements after 0. Repeat the same process with the two new arrays, the left array and the right array. Get the middle element and create a node with its value. Make it the root of a tree. Same thing for array 5, 9. Get the middle element and create a node with its value. Make it a root node of a tree. On the left side, we have f of -10 and f of none. On the right side, we have f of 5 and f of none. -10 is the middle element of a single element array. So create a node out of it and make it a root of a tree. 5 is the middle element in a single element array. Make a node out of its value and make it a root of a binary tree. Left of -10 is an empty array. Remember, if not nums, return none. So we return none. The right of -10 is also an empty array. So f of empty arrays return none. So we bubble up the result. And finally, we return the root. And there you go. We just convert a sorted array to a height balanced binary search tree. Alright, time to smash the submit button. Boom, accepted. And just like that, we build a perfect balanced binary search tree. Time complexities of this solution is O of n because we visit every node once. Space complexity is also O of n due to recursion stack and new tree nodes. This is about a efficient as it gets for tree construction from a sorted array. So that the recursive solution to Leetcode 108 converts sorted array to binary search tree. It's clean, balanced, and leverage the sorted property perfectly. If you found this helpful, check out the other binary videos on the channel. We cover traversal, symmetry checks, and more. I'm Alan.